So today we are going to be talking about binomial radical expressions and radical expressions in general. So I want to talk about adding and subtracting radical expressions. You've actually already done really this whole section, so it's going to feel good. When you add and subtract radical expressions, you need to think of like terms. The roots have to look exactly the same, meaning they have to have the same index, they have to have the same number under them in order for them to be added or subtracted. So for example, 3 root 7 plus 5 root 7. The roots are exactly the same, so just think of them like x. What would you do if it was 3x plus 5x? Well, you'd make it 8x. Okay, you don't change the radicals, you don't multiply the numbers under them. So this would be just 8 root 7. Okay, now looking at the next one, I'd love to be able to add them, but as you can see, the radicals are not the same number, so you can't add them. What you see is what you get, and that is lowest form. All right, I look at the next one. Now I threw in the cubed root. The cubed root, it's the exact same thing. The roots are exactly identical. They both have the same index, and the number under them is the same. So you just treat them like terms. So 8 minus 3 would give me 5. And you get still the cubed root of 7xy. All right, one more. 8 cubed root of 7xy minus 3, fifth root of 7xy. The indexes are different, so you can't add them. Okay? So again, when we're adding and subtracting roots and radicals, we want to make sure that the indexes are the same and the roots themselves are the same. Then you can add. All right, so multiplying binomial radical expressions, just like multiplying binomials. Okay, when we binomial, we've got binomials that we multiply, we FOIL. So we're going to try this. We're going to do the first times the first. So 4 times 5 gives me 20. The outers, so 4 times 4 root 2, be careful, would give me plus 16 root 2. Multiply the real parts, not the radical parts. All right, then the inner term, so 2 root 2 times 5 is going to give me 10 root 2. And then 2 root 2 times 4 root 2. All right, so you got to do 2 times 4, which is 8. And then you have to do root 2 times root 2, which is root 4, which is 2. And you have to multiply those two together. All right, now we're going to simplify and combine the like terms. These are like terms. They have the same radical, same number, so we combine them. So we get 26 root 2. I'm going to multiply 8 and 2 and get plus 16 and 20. Now I can add the 20 and the 16 and get 30 plus 26 root 2. All right, I want you to try 3 minus root 7 times 5 plus root 7. So press pause, try it, and then come back and see my work. Okay, so you multiplied 3 times 5, you got 15. You multiplied 3 times root 7, you got 3 root 7. You multiplied 5 times negative root 7, and you got negative 5 root 7. And then you multiplied negative root 7 times negative root 7, and you got negative 7, or negative root 49, which is 7. Then you combined the like terms, and you got 15 and 8, you combined, and you got 15 and 7, and you got 8. And then you did 3 minus 5, which gave me negative 2 root 7. Again, the only reason we can do that, they are the exact same radical, same index, same number under that radical. All right, let's talk about when we multiply conjugates. Those were just binomials. When we multiply conjugates, something interesting is going to happen. Now, we've said this several times, but I really want us to get into it a little bit deeper. Multiplying conjugates. Watch what happens. 5 times 5 is 25. 5 times root 7 is 5 root 7. 5 times negative root 7 is negative 5 root 7. And then negative root 7 times positive root 7 is going to give me negative 7, root 49, which is 7. The middle terms cancel, and I get 25 minus 7, which gives me 18. What I'm hoping you noticed is what always happens. What always happens is that the middle term cancels out. So do I always need to FOIL if they're conjugates, if I recognize they're conjugates? And the answer to that is no. You do not need to FOIL. You can just use the difference of squares and multiply the firsts and the lasts. It is the difference of squares, guys. Look, x plus 5, x minus 5. That's the difference of squares. And where does that start out at? X squared minus 25. No middle term. It's a binomial. All right, I want you to try. 6 plus root 12 and 6 minus root 12. All right, you paused. I tried it. You should have gotten 36 minus 12, which gives me 24. All right, last thing. Rationalizing the denominator. I know, our favorite. We rationalize denominators that have expressions in there by multiplying by the conjugate. So as a reminder, the conjugate of 2 plus root 2 is 2 minus root 2. The conjugate of root 5 minus 1 would be root 5 plus 1. So I look at this expression, I multiply by the conjugate. The conjugate is root 5 plus root 2. Root 2 over root 5 plus root 2. Then I multiply across. All right, so the numerator, I'm going to put it in parentheses to help. I'm going to distribute. It's not binomials anymore. So 3 root 2 times root 5 gives me 3 root 10. 3 root 2 times root 2 gives me positive 3 times 2. Because root 2 times root 2 is root 4, which is 2. All right, all over. When you multiply conjugates, it's the difference of squares, so the middle term cancels. So we do root 5 times root 5, which is 5. We do root 2 times root 2, which is negative 2, so minus 2. I'm going to simplify. I get 3 root 10 plus 6 all over 3. All right, yes, I can simplify some more. So I'm going to make sure that I can simplify the 3 there and there. So I have 3 root 10 over 3. Plus 6 over 3. These cancel. This goes into 1 to 6 twice. So my answer is root 10 plus 2. All right. I want you to try the next one, 4x. I want you to get rid of the x, though. I made a mistake by putting that x there. So 4 over 3 minus root 6. Pause, try it, come back. All right, you paused, or you better have paused, and you tried it, and then you multiplied by the conjugate, 3 plus root 6 and 3 plus root 6. If you aren't trying it, guys, then you really aren't getting this, and I'm trying to help you. All right, so I'm going to actually put parentheses so I know that means distribute, and I get 12 plus 4 root 6 in the top. In the bottom, it's the difference of squares, because when I multiply conjugates, it's the difference of squares. I don't need to FOIL. So I do 3 times 3, which is 9. A negative root 6 times a positive root 6 is going to give me negative 6. And then I'm going to simplify the bottom, which gives me 3. So 12 plus 4 root 3. And yes, I'm going to simplify the 12 and the 3 and the 4 and the 3. So I'm going to get 4 plus 4 thirds root 3. And there's my answer. All right, so coming on in tomorrow, we are going to review. What I would like you to do, because this was so short, is I want you to do 1 and 2 on the bottom of this page. It's very similar to what we were just doing, and it is review for your March exam. Have a great night.